Hello viewers, welcome back to my channel. Today I'm going to treat a very important topic in chemistry, and that is calculation of electrolysis. If you are new on this platform and you're just seeing my video, you can subscribe, and you're yet to subscribe, please do so by clicking the subscribe button below the video. Like, share, and also comment on my videos. Now, if you are yet to watch the video on the principles of electrolysis, as in a typical example of electrolysis, I made a video on that. Please check that before this calculation so that you can get a thorough or in-depth knowledge of this topic. Now, in calculation of electrolysis, there are two laws of electrolysis that are applicable. The first one is the Faraday's first law of electrolysis, which states that the mass of an element discharged during electrolysis is inversely proportional to the charges on the electrolyte. Hello viewers, welcome back to my channel. Today I'm treating a very important topic in chemistry, and that is calculation of electrolysis. If you are new on this platform, you're seeing my video for the first time, please subscribe by pressing the subscribe button below the video, and also click the like button, share, comment on my videos. Now, under calculation of electrolysis, we need two laws to apply. We are going to apply two laws of Faraday for this calculation. And the first one is the first law of Faraday, which states that the mass of an element discharged, the mass M of an element discharged during electrolysis is directly proportional to the quantity of electricity that is passing through the electrolyte, and the quantity of electricity here is Q. The mass of an element discharged during electrolysis is directly proportional to the quantity of electricity that is passing through it. That is, if the quantity of electricity is increasing, the mass is also increasing. And the second law of electrolysis states that if the same quantity of electricity is passing through different electrolytes, the relative number of moles of elements discharged is inversely proportional to the charges on the ions of the elements. So, applying this principle, we'll be able to solve this calculation question easily. But I will also advise you to watch my video on the principle of electrolysis, how electrolysis occurs, and then some terms that you're supposed to understand before this, because we need to write the equation of reaction for this calculation, and we get the equation of reaction from the theoretical knowledge of the process of electrolysis. So let's treat the first question here. Calculate the mass of silver deposited when a current of 2.6 ampere. Now, silver is written as Ag, and the charges on silver is +1. Now, when it is deposited, when a current of 2.6 ampere is passed through the solution of silver salt for 70 minutes, now we are going to that. Now, let's write the equation of reaction first. For electropositive elements in electrolysis, it is assumed that the ions of electropositive elements in electrolysis has already, they've given out their electrons, and so they need to gain it back. You know, a neutral element, for instance, sodium, which is number 11, 2 on the first shell, 8 on the second shell, third shell has only 1. As giving out only 1 electron it has. And when it gives out the electron, it becomes an ion with the number of electrons given out written on top of it. So from sodium atom, which is 11, it changes to 10, which is sodium ion. So for a neutral element to become an ion, it has already given out electrons. So what happens is that in electrolysis here, if you are writing the equation of reaction for electropositive elements, they will end up going back to pick up the electrons they have lost, because they are going to the, since they are electropositive ions, they are called cations, that is cathode ions. They are going to the cathode electrode in an electrolytic setup to pick up the electrons they have lost. So that is, in that case now, that is gain of electron, and they are going to the cathode. Positive ions called cations, cathode ions goes to the cathode to pick up the electrons they have lost, which is gain of electron, and that is reduction. Whereas it is vice versa for anode. In anode, oxidation takes place, which is loss of electron. Now, so the anode is believed to be electron rich. So any elements going there will be electronegative element. That's the anions, anode ions. They are going there to lose electrons. Normally, electronegative elements usually gain electrons to themselves. For instance, now chlorine, which is number 17, atomic number is 17, 2 on the first shell, 8 on the second shell, making 10, then 7 on the last shell, we're supposed to be 8. So it will gain one more. It can gain from sodium to become sodium chloride. So when it gains, in electrolysis, when it gains, they become ions. When they have not gained, they are just neutral. So after gaining, they become ions. So in electrolysis, they are going back to the anode to deposit what they have gained to become neutral again, and then they will be discharged and be collected. The same thing occurs in electropositive. So I'm going back to silver now. Silver ion will take up 1 electron because the charges on silver is +1. So it's taking up 1 electron and it will become neutral. It will be deposited on the cathode as silver metal, and it will be collected. Now, you have been given the current and the time. So there is a formula which is Q equals to IT. Where Q is a quantity of electricity, the I is the ampere, which is the current, and then C is the time, which must be in second. Now, if you are given time in hours, you multiply by 60 twice. That is, convert to minutes first by multiplying by 60, and also multiply again by 60 to convert to seconds. So let's calculate the quantity of electricity that will yield the mass of silver. So if we have 2.6 amperes multiplied by 70 minutes, 70 minutes here, it will be converted to second. So 70 multiplied by 60. That is 4,200 multiplied by 2.6. So sorry. So we have 0, 0, 2, 9, 10. That is 10,920 coulombs. Coulomb is denoted as C. So quantity of electricity is always in coulombs. And there's a standard which says that 1 mole of an electron is equivalent to 1 Faraday. And 1 Faraday is 96,500 coulombs. So now, the question is, what mass of silver will be deposited when this amount of, this quantity of electricity is passed through it? So there is a standard which says that 1 mole of silver is deposited by 1 Faraday because we have 1 electron here. So that is 1 mole of silver is deposited by 1 Faraday because we have 1 electron. Assuming you have 2 electrons or 3, that would be 3 Faradays, which is 3 multiplied by 96,500. Now, 1 mole of silver, because the question is asking us to calculate mass, 1 mole of silver will be converted to mass, and 1 mole of silver is its molar mass, is a smaller mass, and that is 108, or let's say mass number, that's 108 gram. So we'll say 1 mole of silver, which is 108 gram, will be yielded by 96,500 coulombs. What mass, that's S gram, will be yielded by 10,920 coulombs. So cross multiply, work out your answer. X times 96500 coulombs equal to 108 multiplied by 10,920. Divide both sides by 96500 coulombs. So work it out and get your final answer. That is the answer in gram, because we are asked to calculate mass. So for a quantity of electricity that is put into the electrolyte, it is directly proportional to the mass of the elements discharged during electrolysis. Let's look at another question here. This one is just as straightforward as anything. What quantity of electricity was consumed in 1 hour during electrolysis? Using Q equals to IT. We have the ampere as, okay, the question is incomplete. What quantity of electricity was consumed in 1 hour during electrolysis into using 2 amperes? So Q here is 2 multiplied by the time T, which is 1 hour. That is 1 multiplied by 60 multiplied by 60, and that is 7,200 coulombs. Now, because ampere here is for I, while T is time, let's look at another question here, and that is 0.22 gram of a divalent metal. In this case now, the metal was not mentioned, but divalent means that it has 2 charges on top, plus 2 on top. Because it's a metal, it is positively charged, and it has 2 electrons on top. Of a divalent metal is deposited when a current of 0.45 ampere is passed through a solution of its salt for 25 minutes. So these 2 information here, 0.45 ampere and 25 minutes, will actually lead us to get the quantity of electricity that was passed through it. So 0.22 gram of that metal was discharged when 0.5, when so quantity of electricity was passed through it. So we have to calculate the relative atomic mass of the metal. That is, they are asking us question from the back, because we want to, if we get the relative atomic mass of the element, we already know the element. So they've given us the mass of metal that was deposited, and then the quantity of electricity that also passed through it. We can also get that one by multiplying 0.5 ampere with the time in second. So what we need to know to do is to get the second line. And so let's write the equation of reaction first. A divalent metal has plus 2 on top. Let's assume M is the formula of a metal, plus 2E minus, that is, they will pick up 2 electrons and become a neutral element, meaning that 2 Faradays here liberate 1 mole of M, and 2 Faradays, 2 multiplied by 96,500 coulombs, liberate 1 mole of M. And 1 mole of M is its molar mass or atomic mass, which is the relative atomic mass in details. So we have 2 times 96500 coulombs gives us the relative atomic mass of that element. That is a standard from the question, or from the an established standard. We get the first line from the equation of reaction, since we have just 1 mole of M here, which is 1 mole of any element is its relative atomic mass, or the mass number. And so we have gotten the first line here. The second line now, we are going to get it from the question. So this side is supposed to be gram. So quantity of electricity is supposed to be here. But here now, we were not given the quantity of electricity directly, but we were given the information to get it. So using Q equals to IT for the second part. So Q is 0.45 amperes multiplied by 25 minutes, which is 25 multiplied by 60. Let's work that out. 25 multiplied by 60. 12 plus this 1,500 multiplied by 0.45. 045 0 0 25 2 75 0 0 0 2 6 0 0 0 0 0 0 5 7 6 0. So we have 1 2 675 columns. So Q equals to 675 columns, meaning that for the second line, if 2 times 965,000 columns is the relative atomic mass from the equation of reaction, 2 times 2 electron, that's 2 times 1 mole of electron, which is 96500, is its relative atomic mass, that is liberates 1 mole of M, which is relative atomic mass. So 675 liberates 0.222 gram. So let's work out the relative atomic mass. So what you will get here is RAM equals to 2 multiplied by 96500 multiplied by 0.222 all divided by 675, and we get our answer. So we have a similar question here, which is calculate the mass of aluminum deposited when a current of 3 ampere is passed through an aluminum electrolyte for 2 hours. You have to convert the 2 hours to seconds, which is 2 multiplied by 60 multiplied by 60, and then the 3 amperes there with the time will give you the quantity of electricity. And aluminum here is an electropositive element that has 3 plus 3 charges on it. Now, if you are dealing with oxygen in electrolysis, oxygen is actually liberated anytime hydroxy ion is deposited, and we usually have 4 faradays of electrons liberating 1 mole, just 1 mole of oxygen. And oxygen is diatomic, that is O2, 16 multiplied by 2 to get the molar mass. So for all the atomic elements, we have to be very careful. We multiply the atomic mass by 2. If we are dealing with chlorine, for instance, now, by the time we balance the equation of reaction, chlorine will end up having 2 moles of electron, which is 2 times 96500 coulombs. We will liberate 1 mole of chlorine, which is just Cl2, that is 35.5 multiplied by 2, which is 71 gram. So we should be careful when we are dealing with questions like this. Watch out for my videos on the principle behind electrolysis. I'm going to give you 2 examples of electrolysis and what is yielded at the end. If you are yet to subscribe to my channel, please do so by clicking the like button below the video, and share my video, like my video, and comment on my video. You can also press the notification bell to get alerted anytime I drop new videos. Thank you.